Hi everyone, my name is Ainhoa Genua, and the purpose of this video is to explain what an interference pattern of waves is, and why does this phenomenon happen. An interference is a phenomenon in which two waves superpose generating different maximums and minimums of intensity. This happens, above all, when the waves come from the same source. In the case presented on the screen, the waves are emitted from a source that discharges them with an 800 meters per second propagation speed. These waves are emitted to a screen but not in a simple way. As we can see in the screen, waves are emitted in a way, but in the way to the screen, there are three sheets generating two slits, which generate the diffraction process of the waves. After this diffraction is when the waves start to superpose each other, generating the maximum intensity points that will be represented afterwards on the screen here. This intensity varies depending on the different factors and different variables, such as the length of the wave, the initial amplitude of the wave, the distance between the sheets and the screen, and the distance between slits. On the other hand, the intensity changes when analyzing different points of the screen, but it is necessary to analyze a lot of different points of the screen to know how the interference of the waves works. This simulator provides the opportunity to experiment this phenomenon in an original way. First of all, it's important to choose in which situation you want to analyze the results. We are going to choose this situation even if there are plenty of options. After this, the animation should be turned on, and we'll be able to see after a few seconds how the pattern of this interference is. To understand this phenomenon, it's important to know that the maximums are represented with yellow color, while the minimums are represented in black, as it is shown on the screen. On the other hand, there appear to be some auxiliary points, like these ones, in pink, green, blue, and red, even if in this situation we don't see pink points, in other situations we'll be able to see them. These are auxiliary points which represent the interference of the waves. As we can see, this wave interferes with this wave in this point, and this point. These points generate an imaginary line which goes to the maximums of intensity represented on the screen in this way. In fact, as we change the value of these variables, the auxiliary points and the waves are not going to be in the same position, as these points always tend to lead to the maximums of intensity represented on the screen, and the maximums are not going to be always the same. Let's change some of these variables to see how it will work changing them. For example, if we make the original amplitude of the wave larger, we'll see what happens. As we are able to see right now, more or less, this line of pink point tend to go to this place, the green ones to this place, the blue ones this place, the red ones this place, and the same on the other side. If we change it again, but this time we change the length of the wave, we'll be able to see that the intensity is not going to reach those high points reached before, as we can see that there are no yellow colors, but there's going to be a difference. The points are not going to be just all black. We'll be able to see some clearer places, such as these ones. If we change the distance between slits, again these points lead to these yellow points, these ones, and it happens this all the time. As we see, changing the variables, the the interference pattern changes a lot. The last variable to change will be this one, the distance between the sheets and the screen, and we'll be able to analyze different situations again. But this is not the only way in which the variables could be changed. As well, we could put this 10 but also make this larger, and it will also change. So as we have proved, this is just a matter of time, because there are plenty of ways in which the results could be analyzed. It's just taking time and seeing how the waves change and how the pattern changes. And this is everything for now, and I hope everyone will have understood how an interference pattern works, and I hope you have enjoyed the video. Thanks for your attention. Bye.